What if your own language model could search the web and answer real-time questions? Just like ChatGPT, but running locally on your system inside your app where you have full control. That's exactly what we will build today. We will make a beautiful interface where language models have full access to the real world. For this, we will dive deep into MCP, or Model Context Protocol, that gives AI models a whole set of superpowers. And as usual, we will build everything from scratch, using Ollama for the model, Langchain to pull it into Python, Streamlit for the GUI, and the brand new Bright Data MCP fresh out of GitHub to give our model unlimited real-time access to the web. So are you ready? Let's roll! So first of all, what exactly is an MCP? MCP stands for Model Context Protocol. It's like a manual or a handbook that helps AI models receive information from the outside world, which is usually off-limits. This information could be files, web pages, or databases, or it can also be services like Discord, GitHub, Shopify, or Amazon. Basically, anything that the model doesn't already know. So no need for training or fine-tuning, just send it the resource and the model will read it. Take Discord, for example. Let's say you're running Llama locally and you connect it to a Discord MCP server. This server is built by Discord themselves, and it can access your personal account using a unique API key. You create the key in your account settings, you pass it to your program, and just like that, your model logs in. So if you say something like, ask on all my channels if someone wants to play GTA, then Llama will go ahead and post it for you. Seriously. But how does it work? Well, let's use a quick analogy. Imagine that your computer is a school, and inside that school there are different rooms, a gym and a science lab. In the gym, you will find things like tennis balls. In the lab, you will find things like microscopes, where each room has its own purpose and its own specialized equipment. You don't want any baseball bats in a lab full of glass, right? So in this analogy, the rooms are your MCP servers. The students moving between them are your client. And if you're not sure what a client is, it is either a device or a program that communicates with a server. It can receive and request information. Now, each server has a set of tools that the client can use depending on the nature of the task. For example, let's say 2 students are eating in the lunchroom using plates. Another one is writing an essay in a classroom with a pen. And another one in the same classroom is browsing YouTube on their phone. But instead of dealing with 4 clients, we are only dealing with 1. This client performs all these 4 student tasks at the same time asynchronously. Not one by one, but all at once, which gives us maximum performance with only a few clever lines of code. Now, in our case, we are not writing essays, we are doing web search. And theoretically, we could build our own MCP for web search rather than using an existing one. But here's just one problem. Most websites can easily tell if you're a human or a bot. And if they only suspect that you're a bot, you get blocked, blacklisted, shown a bunch of CAPTCHAs, location restrictions, or even served complete nonsense just to mess with you. True story. Try asking Grok about specific lines of code in a GitHub repository, or ask ChatGPT about your video description on YouTube. Good luck! So instead, we'll use a specialized MCP server just released by Bright Data that automatically solves all these issues. It combines proxies and physical browsers for interacting and not just reading the web. As a result, the nice little app that we're building today will browse the internet just like Grok's deep search or ChatGPT's web browsing features. In some cases, even better. And sure, they've got a bit more computing power than us, but you will see very soon that we don't actually need it if we use the right tools. Alright, so now that we know what we're dealing with, let's go ahead and set up our server. For this, we will navigate to Bright Data using the link in the description. Why? Because it gives you $15 of credits, which is way more than you need for this entire project. Now let's go ahead and log in, and we will then navigate to our Proxies and Scraping tab, where we will add a brand new Web Unlocker API, which is what our MCP relies on. Now, let's go ahead and choose a zone name, in my case, Unlocker MCP. And in my case, I will also enable the premium domains because today I'm going all in. Now let's go ahead and click Add. Now, once we have a new Unlocker zone, we will go ahead and navigate to our account settings where we will create a brand new API key. For this, we'll click on Add Key. We will give it some administrative privileges and we'll also set it for an unlimited expiration date. Once we are ready, we'll click on Save, and beautiful, here's our lovely API key. Now, a great way to handle these keys is storing them in our console environment. For this, we'll quickly copy this key and we'll open our Linux file system on our Windows machine. Now, if you don't have one already, check out my WSL installation tutorial. Why? Because traditionally, when we're dealing with servers, we are using Linux. Now, we will navigate to our root directory, which in my case is Ubuntu, followed by Home, followed by Maria. And then in our root directory, we will find a file named .bashrc. So let's go ahead and open it. And if you're not familiar with this file, it stores special settings that are executed every time we open a new WSL terminal. So for example, at the very bottom, we will create a new environment variable with export. We will call this variable BRD, as in Bright Data API key, and we will assign it to the string we just copied. Now, once we save this file and we open a brand new instance of a WSL terminal, and if we type echo followed by a dollar symbol and then BRD API key, we will then access the content of our variable that we just saved in our bashrc file. Great. Now, to run our MCP server, we will first need a working environment. So let's create it with conda create -n. We will call it MCP env, and we will install Python 3.12 init. We will then activate it, of course, and we will install Node.js inside it with conda install Node.js. Now, if you're wondering, why on earth are we installing JavaScript in our Python project? That's because the Bright Data MCP is written in JavaScript. We can use any language we'd like on the client side, but the server side needs some JavaScript installed. So let's go ahead and proceed with why. And now, once Node.js is installed, all we need to run our server is typing API token, which we will set to our environment variable of $BRD API key, followed by the running command of npx, followed by the module name of @brightdata/MCP. Now, once we run this command, then our server is officially running. Yay! Now, if on your end you are getting a similar error to mine, then there's actually a very quick fix. All you need to do is collapse your server with Ctrl+C, and then we will pull our most recent command, and right after API tokens, we will add a web unlocker zone. We will then set it to the name of the zone we just selected in our browser, in my case, Unlocker MCP. Now let's give it another run. And once again, our server has started, but this time we are no longer getting the error from earlier, and everything is just rainbows and butterflies. Okay, but what are we supposed to do with this server? Well, first of all, let's create a new Python file and let's save it as mcp app.py. And then this file will be our client. For this, we will need to translate our JavaScript command from the terminal into a Python equivalent that can run in our file. This command will include a runtime, a path to our server, as well as our API token. So let's start with the easiest part, which is our API token. So back in our Python file, we will first import the OS module, and then right below we will type os.environ.get, to which we will pass the name of our environment variable BRD API key. And then to keep things consistent, we will give this expression the exact same variable name. Okay, but how about the rest of the command? How are we supposed to translate this npx thing? Well, for this, we will need a way of taking our terminal command into our Python file, which is something that we do with a module named Langchain. So let's go ahead and collapse our server with Ctrl+C, and then let's pip install Langchain _MCP _adapters. And then once the installation is complete, back in our Python file from Langchain MCP adapters.client, we will import the multi-server MCP client class, hopefully with no typos. Then we will copy the name of the class and we will initialize it below, followed by an empty set of round brackets, and we will assign it to a variable of MCP. Now, this object expects credentials that we can copy from the official Bright Data MCP repository on GitHub. We'll just scroll down and we will copy this JSON object that looks a lot like a Python dictionary. So let's just press on this copy button and we will then pass it inside our multi-server MCP client object. And let me quickly make the font a bit smaller, and great. Now, at this point, we are only dealing with a single server. So in our case, we can go ahead and delete this MCP servers wrapper, including the closing curly bracket at the bottom. Then we will also get rid of this browser zone because we won't be using it in our project. Then we'll just replace this placeholder text of our unlocker zone with its actual name, in my case, unlocker MCP. And then, of course, we will assign our API token to our BRD API key variable. Now, on many systems, this server will work like a charm. But for some reason, on my end, I can't seem to run it. So here's what I did to solve it. Now, instead of running our server with the npx command, we will run it with node, as in node.js. And then instead of specifying the node module, we will specify the path to its main executable file. We'll just go back to our file system, and then from our root directory of, in my case, Maria, we will type in the search field @Bright Data, which will of course find our node module, and inside it our MCP directory, and then our main executable file will be server.js. I hope you can see it well. Now this server.js file is the exact file we're looking for. So let's go ahead and copy some of this path from above, everything that comes after home/Maria. So let's copy this path and let's replace our @brightdata/MCP with it. Then we will replace all the backslashes with a slash. There you go. And we will of course add to the very end our server.js file. Now, there's just one problem. This path will only work if our Python file is stored at the root directory, which is not the case on my end. On my end, it is stored inside the MCP project directory. So the only way to reach .npm from here is to go one directory back, and only then we see this .npm folder. So in front of it, we need to add a // path. And now it will work like a charm. Okay? Now there's one more thing we need to specify here, and this would be our transport. And in our case, since we are running our server from a local JavaScript file, our transport would be std, as in standard, IO, as in input output. It looks a bit like Studio, but it is not. Now, the other option we have here is HTTP, which is something we use when we run remote servers. Great! So this should properly connect us to our server. But a connection is not enough. We also need to communicate with it. And since MCP servers are asynchronous, we communicate with them through asynchronous functions. For this, we'll go ahead and import the Asyncio module, and it will help us slightly tweak our functions so that they are asynchronous. For example, to create an asynchronous function, at the very bottom, we will type async followed by def, as in define, and then the name of our function, which is MCP Tools. Now, we will use this function to fetch all the available tools from our server and to print them one by one. For this, we will type await followed by mcp.get_tools. And why MCP? Because that's the name we gave to our multi-server MCP client. And this class has a method of getTools. Now, since this method is fetching those tools, let's store them as a local variable named tools. And then right below, we will print each of these tools with for index tool in enumerate tools, and we will then print the index right beside the tool.name. Now, another important piece of information that we need from our tools is the arguments that they expect. For this, right below, we will print the tool.args, and then right below, we will print a separator of a whole bunch of asterisks. And then, since we defined a function, we also need to call it. So at the very, very bottom, we will type asyncio.run, to which we will pass the name of our function, MCP Tools, including the round brackets at the very end. Now let's go ahead and save this file, and then back in our terminal, we will first navigate to our project folder, in my case, cd MCP project, where our Python file lives. Now, to run this file, we will go ahead and type python3 mcpapp.py, and holy smokes, I didn't have any typos. What? And beautiful. Here's a list of all the available tools that we can use in our project. So for example, we can expose our language model to a whole bunch of posts on Reddit. Or we can expose it to YouTube comments, or even some complex stuff like GitHub repositories. And these tools will give us the information in real time as it appears on the website right now. Now, another important thing you may have noticed is that most of these tools are only expecting a URL. So here's what we can do. We can say that if the URL starts with Instagram, then use one of these Instagram tools. Or if the URL starts with LinkedIn, then use one of those LinkedIn tools. And that way, we can plug in all these different tools into our program in a single conditional statement. We simply look at the URL, and then based on the content, we decide which of these tools is the most appropriate for the task. So for example, let's choose one of these tools. In my case, I'll go for the scrape as markdown tool at the index of 1. And this tool only expects a URL in the form of a string. So back in our code, we will first return our list of tools from our MCP Tools function with return tools. And since our function now has a bunch of output, we will go ahead and assign our function call to a global variable of tools. And then we will need an additional asynchronous function to fetch these tools and to determine which of them we will use. So below our MCP Tools function, we will define a new asynchronous function named handle_prompt. And this function will receive our tools from earlier. Now, the first thing we'll do is select the tool at the index of 1. And then we will assign it to a local variable of scraper. Now, to run this tool, we will simply type await followed by scraper.a invoke, and we will pass it our argument of URL in the form of a dictionary, where the key is equal to URL and the value is equal to some kind of a link. In my case, I'll just copy the URL of one of my blog posts. Now let's go ahead and paste it back in our code. And yes, the URL key must be a perfect match to the URL argument we received in the terminal. So let's go back to our code and then let's fetch the output of our invoke method, where the output is simply the text content of this web page we just shared. Now let's go ahead and store it as result. And then right below, we can go ahead and print this result, and we can also return it at the end of our function. Now, the last thing we need to do is to call this function, and we will do so with asyncio.run once again. It's just that this time we will pass it handle prompt with the argument of tools. And hopefully my head doesn't block it. So let's save this code. Let's go back to our terminal, and then we will rerun our code, which hopefully scrapes my blog post. And okay, it did scrape something. I can see my name here, but let's make sure it's my blog post indeed. And yep, it is my blog. We can finally move on with language models. For this, we will install Ollama, which is a popular platform that helps language models run directly on our system. So only you have access to your chats, keeping things extra private. So let's quickly navigate to ollama.com and let's click on this download button. Then we will choose our operating system, in my case, Linux, and let's copy this installation command and paste it in our terminal. Let's give it a quick run. And beautiful! Ollama is officially installed and it now lives in this port on our system. Now, Ollama is a very simple tool, and the most difficult part about it is choosing the type of model we want to work with. So back in our browser, let's click on Models, where you will find all kinds of goodies. But in our case, we will go for the most capable model, according to Ollama, which is Gemma 3. Now, believe it or not, but the only thing we need to run this model is simply typing Ollama run Gemma 3. Now, if your system is not very strong, or if you don't have a GPU, then maybe go for Gemma 3 1B, as in 1 billion parameters, which is the smallest version of this model. Now, in my case, I do have a GPU, so I'm just gonna go for the default one. Now let's give it a go. And perfect. Let's quickly test it. Let's ask it how many days in a week. And perfect. There are 7 days indeed, and we even get a very nice emoji. Aww. Now let's ask it another question just in case. Let's say, how many stars in the universe? Okay, let's see how it handles it. And okay, that's a lot of text, but as you can see, everything works like a charm. But how do we take our conversation from the terminal and pull it into our Python file? Well, just like earlier, we can use Langchain. So let's quickly finish our conversation with /by, and let's go ahead and pip install Langchain _Ollama. And then back in our Python file, at the very top, from Langchain _Ollama, we will import the Ollama LLM class, hopefully with no typos. And then right below, just for testing purposes at this point, we will initialize this class, and in a set of round brackets, we will specify the model of Gemma 3. Then we will assign this expression to LLM, as in large language model. Now, if you've downloaded Gemma 3:1b, you need to adapt the name here as well. Okay, now to have a conversation with this model, we will do something very similar to our communication with the server. Okay, what do I mean? The way to prompt our model is to type LLM.invoke, passing it some kind of a prompt, let's say, how are you? And we can then assign this expression to LLM response, and let's print it right below. Okay, let's just copy this variable name. Okay, and let's comment out the rest of the code. Okie dokie. And let's save this file and let's run it just for testing purposes. Okay, we will type Python 3 MCP app.py. And perfect. Here's our model response, and we are officially communicating with Ollama through our Python file. Yay! Now, our next task is to pass information from the MCP into our model. For this, we'll quickly copy our LLM block and we'll paste it at the bottom of our handle prompt function. So let's find it. Ooh, there you go. And let's paste it, fixing our indentation, of course. Now, our goal here is to connect the result from our scraping tool with some kind of a user prompt. So for example, let's create a user prompt and we will assign it to what is this website. But we can't just connect them arbitrarily. We will need to label the result of our scraping tool as context and our user prompt as question. For this, we'll create a new variable. This time, we will call it full prompt, and we will assign it to a set of concatenated strings. What do I mean? Well, the first string would be context, and we'll specify that the context is a bunch of scraped data. We will then wrap this string with a colon as well as a double new line operator. And then this double new line will act as a separator. You will see what I mean shortly. Now, in the next line, we'll go ahead and concatenate the result from our scraping tool, the one that we got right over here. Okay? Now, since this result includes a whole bunch of new lines in it, let's also strip it from all the white space. And that way, the only place that we will get these double new lines will be this context string. Okay? Very important. And then right below, we will concatenate another string, but this time it would be question. And we'll, of course, wrap it in a double new line operator from both sides. And then finally, the last thing we will concatenate would be our user prompt. And with this type of structure, our model knows exactly what we want it to do. And before we move on, let's quickly fix my typo. It is strip and not steep, okay? And then another thing we need to do is instead of hard coding our how are you prompt, let's pass it the full prompt, which is generated like so. Beautiful. Now, since our model response is partially based on the result from our MCP, we no longer need to print the result. Ooh, sorry. There you go. And instead, we can return the LLM response itself. Are you ready? Let's give it a save. Let's go back to our terminal and let's run our program once again. And okay, we got a response from the model. Now let's make sure it's the proper response. Okay, let's find where it starts. This website is a tutorial and documentation for a project called Stable Diffusion GUI app. Amazing! So everything works like a charm. Now, another thing you may have noticed is that this model response is fully formatted. There's a bunch of bold text, and there's a bunch of headings, and there's a bunch of lists, and so on and so on. So printing it in the terminal is an absolute waste. Let's wrap it in a beautiful application with some inputs and buttons and all that jazz. For this, we'll use a web framework named Streamlit. So let's quickly install it with pip install Streamlit. And then back in our code, we will import it with import Streamlit as st. Now, usually, designing GUIs takes a bit of time, but not so much with Streamlit because it has a very friendly syntax. So let's quickly scroll to the very bottom of our code, and here we will create an st.title with the text of internet emoji followed by LLM web search. And then right below it, we will create an st.text input with the label of enter URL. And then in addition, we will need an st.text area, which is slightly bigger than the text input, and we will give it the label of enter question. And then finally, we will also need an st.button with the text of submit. Now, before we add functionality to these elements, let's make sure they look good. So let's save this file, let's navigate to our terminal, and let's run our app with Streamlit run MCP app.py. And beautiful, our app runs in the port of 8501 on our system. So let's quickly navigate there. We'll just paste it in our browser, and beautiful! Here's our lovely interface. It is already perfect. We don't need to do much. But the only problem is it doesn't have any functionality yet. So let's fix it. So first, let's assign our text input to a variable URL. And then right below, we will assign the text area to user prompt. And then finally, we will assign our button to submit. And now, once we have names for these elements, we can officially manipulate them. So first, let's attach a callback to our button. So right below, we will type if submit, and I know it looks a bit weird, but this is how callback functions look like in Streamlit. Even though we are dealing with a conditional statement, it is only being activated when we hit the submit button. Now, the first thing we'd like to do here is display a message to our users. We want them to be aware that the app is doing something while we are waiting for the model response. So let's type with st.spinner. We will display the message of processing. Okay, my head is probably blocking it. And then right below this message, we can call our handle prompt function. Now, the reason I've put it in a comment is because we will need to slightly revise it. Why? Because now we receive two inputs from the user. We receive the URL, and we also receive a different question every single time. Okay, so in our function, we will need to pass our two inputs as arguments. Okay, so in addition to tools, we will also pass URL as well as user prompt. And then instead of the hard-coded URL, we will replace it with our new URL argument. And then when it comes to our user prompt, our local variable, we will just get rid of it. And that way we receive it directly from the function, and we then pass it to our model. And all of it is being received by our user prompt text area. Okay? I hope it makes some sense. So now, instead of calling our function arbitrarily here, let's call it in the designated space that we just made for it. And then instead of passing it our tools only, we will also pass it our URL as well as our user prompt. But that's not all. To remind you folks, we are now returning the response of our language model. So when we make a call to this function, we will also need to collect the response. So let's assign it to a variable of LLM response. And then since we are collecting this response, we will also need to display it to our user. So right below, we will type st.write, and we will pass it our LLM response. Whew. Now let's see how it looks like. And now we will pass it a different kind of URL, this time my cloud computing blog, not my Stable Diffusion one. Okay, very, very different. We will paste it as URL, and we will ask it a question of who wrote this article. Okay, now let's press submit. And beautiful, here's our processing spinner. And okay, here's our model response. This article was written by Maria Shah. Amazing. But so far, we are only using a single tool. So let's plug in a few more of them. Now, the tool I'll be plugging in on my end is called Web Data Reddit Posts, and it is located at index 45. So back in our Python file, at the very top of our handle prompt function, we will add if URL dot starts with, to which we will pass a string of https reddit.com. And if that's the case, we will set our scraper as the tool at index 45. Otherwise, we will need an else clause where we will keep scraper as the tool at index 1. Now, if we'd like to add another tool, let's look for something fun. Let's say this web data LinkedIn posts, the tool at index 17. Then we will add an else if clause where the URL starts with the URL of a LinkedIn post. So let's quickly copy it. And that would be linkedin.com/feed. Let's paste it back in our starts with method. And if that's the case, we will set our scraper as the tool at index 17. Okay? Now, if we save this file, and now let's try to paste a Reddit post, okay, about an Elgato prompt. That's the latest post I read there. And then we can say, who wrote this post? Let's see. Okay, this post was written by the Devastator. Let's check it. And yep, it is the Devastator. Amazing. Now, to save some time, let me show you what else we can do with our app. And this code is, of course, available on my GitHub under Advanced MCP App. Now, the first thing we can do here is we can keep this URL field optional. Because sometimes we just want to chat with the model. We don't necessarily want to send it a bunch of links. Now, secondly, we can cache the content of our scrape data and we can reuse it in follow-up questions. So for example, we can send it a URL of my blog. There you go. And our first question would be who wrote it? Now, to get a response, it will take quite some time because our model will scrape the data and only then it will calculate the response. And then eventually it will tell us that Maria Shah wrote it. Okay, now our follow-up question, on the other hand, which is a much more difficult question of what is this all about? Once we hit submit, we will get our response almost immediately because our data has already been scraped in the previous question. We just stored it in memory and we used it from there. Now, the way to do so in code is by using Streamlit sessions. And thank you so much for watching. If you found this video helpful, please share it with the world. And don't forget to leave it a huge thumbs up and all kinds of comments. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you soon in an awesome tutorial. So in the meanwhile, bye-bye.